how do we study systems that are in rotational equilibrium? Now, as the name suggests, this means that the system isn't rotating. And so we have this common little method to break down rotational equilibrium problems, PACE. P stands for pivot. Any rotational equilibrium problem must start by you choosing a pivot. So let's look at a simple example. Let's say there's a wall and a floor and there's a ladder leaning like this. Okay, now where would you put your pivot? Now the rule is if the system is in rotational equilibrium, then your pivot could be any point in space. It could be here, it could be here, it could be here, no one cares. So where do you put it? Well, typically, I would put the pivot in a place where I get rid of some of the more complicated forces. And so if I look at this ladder, the forces could include the weight over there, some normal contact forces like so, maybe a friction like this, maybe another friction like that. Okay, and so as you can see, a nice place to put the pivot might be here because you get rid of two forces. Remember that when the force passes through the pivot, it doesn't create a moment, so it comes out of the equation. And similarly, I could pivot the system here. Now, for demonstration purposes, we're going to choose our pivot to be there. And then the next step, of course, is to calculate all the anti-clockwise moments. So which forces here create an anti-clockwise moment about this pivot? Well, we can choose them, okay? Now this guy, well, I would say this guy is creating an anti-clockwise moment, isn't he? Right? If I think of the line of action, okay, this goes to something like that. It's pulling this thing anti-clockwise. Okay, what else? Well, that's all. So that's my anti-clockwise. And then, of course, you consider the clockwise moments, and you realize that both of these guys are creating clockwise moments. And once you calculate all these moments, you simply have to equate them. And so in this case, the moment created by the friction plus the moment created by the normal contact force up there must equal to the moment created by the weight. And sub in numbers, solve for unknowns, and there you go. That's how we break down a rotational equilibrium problem.